All right, let's mess with some decimals. I think this is actually pretty cool. I don't know if you're going to find it cool, but I find it cool. But I'm a nerdy math teacher. Let's go. Let's look at this problem. We just want to write this repeating decimal, 1.035, with the 35 repeating forever. So 1.035353535353535. Yeah, and we're going to write it as a geometric series in order to write it as a fraction. Because do you know that if you have a repeating decimal, it's a fraction? You know how like pi can't be represented as a fraction because nothing repeats? But if it repeats, that's some sort of fraction. Maybe you learned that new. I know I learned that new in the Calculus 2 class. I was like, I'll be damned. I had no idea. So let's just write this first. So 1.0353535. And that's all I'm going to write for now. I think that's plenty. And I claim this to equal 1 plus. So there's the 1 handled. Let's call it 0.035. So now we've just handled that part. Now I want to add it to 0.123, and I want to add in this part. And then lastly, I want to add in that part, so we need 5 decimals before it. 5. And it continues on. Dot, dot, dot. Darn. It's going to go on forever and ever and ever. But this, my friends, is a geometric series. It's a geometric series. Can you figure out what A is? Can you figure out what A is? A is the first term. It's telling you what this thing is. We're not taking the 1. The 1 is going along for the ride. Because we're not worried about the 1. I can represent the 1 in the fraction. Look. 1 and some freaking change divided by. So the 1's not an issue. We're worried about the rest of it. Or the first term is our A. But what's our R? Well, our R is 0.01. Do you see it? What's 0.01 times 0.035? Oh, it doesn't matter because that would have been the 0th term. Oh, I'm sorry. Really, the game, to figure out what R is you're going, okay, well, how many more decimal places? Look. This one has 3. This one has, how many? 5? So we need to give it 2 more. So if this one has 3 decimal places before the 3-5, and this one has 5, that means that, well, we had this, it was our A times our 0.01 to the first plus our A times our 0.01 squared. And then it's going to be our A times 0.01 cubed. Hey, we got ourselves a fun-filled geometric series. This making sense? Hope so. If not, do practice. You'll get better at it. So what we're going to end up with, we're like, oh, I got this thing. This is equal to 1 plus our A over 1 minus R. But we know our A. It's that 0.035 all over 1 minus our R, which is 0.01. Now let's do this without a calculator, huh? This is 1 plus, and that's clearly going to be 33 over 990, right? Or 35 over 990. Clearly, right? Come on, man. So then when you just put this together, you're going to end up with 205 over 198. Of course. I'm cheating. I'm looking at the freaking stuff. I'm not doing this in my head. Glue? Nah, you have to do a hell of a lot of work down here. And I've always been told by students, I'm much better with decimals. No, you're not. You're better with fractions. So a problem like this, if it was to pop up on a test, I might just ask you to go to here. Just be like, oh, get that thing set up. Go write it as a geometric series, and then maybe add, I'll kick you an extra point if you can actually get that turned into turned into a fraction. Like, how would you even turn that thing into a fraction? What would you ever do? You know what I mean? Maybe like 0.035. Sorry, I can't help myself. Math teacher, you know what I mean? And this is going to be 0.99. 0.99. Would you mind if we just got rid of some of these frickin' decimals? You know what I mean? What is there? 1, 2, 3, 4. So let's multiply it by 10,000 over 10,000. So wouldn't this be... Oh, that'd be 35 over 1, 2, 3, 4, 5. Oh, no, I only need to move it over 4, not 5. Just 4. 1, 2, 3, 4. So we didn't have zeros and zeros, so we get 35. What am I doing wrong? What am I doing wrong? Oh, I see what happened. I'm like, something's wrong. I added one too many zeros. We didn't need to multiply by 10,000. We decided to multiply by 1,000. Sorry if you're screaming about that. So 1, 2, 3, we get 35. 1, 2, 3 to here, we get 990. Then you could reduce your fraction, right? What is that going to be? 7 over? Just showing you it's possible. That's all. Oops, 5. That's going to get a 4. That's going to be a 9. That's going to be a 45. That's going to leave with a 40. We get what? 198. And then you get 198 over 198. And then we get 205 over 198. Oh, maybe this is solvable. Maybe I would just have to go to the answer. Maybe I wouldn't. I don't know. Numbers, fun stuff. Just a thought. If you want to try something out, just kind of take a look. Could you figure out what this is? 0.125, 125, 125, 125, which is 0.125 repeating forever. Could you figure out what a fraction would be for that? Figure that piece out. It's going to be some sort of answer, so think about it. This could be maybe an example you do by yourself. Hold on, let me take a picture of that, though. Let me take a picture of this. Yeah, let me take that picture. So when I go to make your test, I'll remember that one. I'll go back and look through my pictures and see which ones we have. And that'd be kind of cool if you did that problem and then it turned out to be on the test. And you're like, I already know the answer. It's going to show it. I'm not promising, but it is on my list. So you do you. Practice. Don't practice. Do your homework. Don't do your homework. Fail. Pass. Be awesome. But you're going to be awesome no matter what. Whether you do your homework or not. All right, I'm done babbling. No, I'm not. I'll be back in a minute.